To understand how we can get a basic feasible solution, in other words, one of the corner points off the region that we're talking about here, we need to realize that the augmented matrix that we've come up with corresponds to a system with 6 variables and 4 equations. Normally, if we have a system with equal numbers of variables and equations, I can solve that for a unique solution. But this is a dependent system. It's like I have a bunch of rows of zeros here, and because I have more variables than equations. What this tells me is that there's an infinite number of solutions to this system, and I need to have a way of figuring out somehow how one of those infinite numbers of solutions corresponds to my corner points. And to do that, I'm going to use basic and non-basic variables. So let me show you how that works. Here we have the augmented matrix, the initial simplex tableau. And what I'm going to do is I'm going to solve this for S sub 1, S sub 2, and S sub 3. This is going to be like I'm working with 2 parameters, because remember I had 6 equations, 4 variables, so I'm going to end up with 2 parameters. I've taken the first row here, 2, 3, 1, 0, 0, 0, 11, and I've written that back in its equation form, which is 2x1 plus 3x2 plus s1 equals 11. And I've done the same thing with my other 2 constraints. What I want to do is take these 3 equations and solve them for s sub 1, s sub 2, s sub 3 in terms of x1 and x2. So I'm going to move the terms with x1 and x sub 2 over to the other side. So what that leaves me with is s sub 1 equals 11 minus 2x1 minus 3x2. The second equation is s sub 2 equals 20 minus 5x1 minus 2x2. And the third equation is s sub 3 equals 4 minus x sub 1 minus x sub 2. The key thing to remember is because x1 and x2 are kind of playing the role of parameters here, I can pick these to be anything that I want. What I'm going to do is pick it in a very special way. We need to pick these values so that they give me a basic feasible solution, something that corresponds to the corner points on our feasible region. In a feasible solution, all the variables must be non-negative. So we're going to take and set 2 of the variables equal to 0. In this case, we're going to take x sub 1 and x sub 2 and set it equal to 0. So if I put in 0 in place of x sub 1 and x sub 2, the first equation gives me s1 equals 11. The second gives me s2 equals 20. And the third equation gives me s3 equals 4. These non-zero variables are now the basic variables. The variables that I set equal to 0 are the non-basic variables. And if you think about it, this is what's going to give us our corner point. In general, if there are m constraints, there's going to be m basic variables. The other variables, excluding z, are the non-basic variable and are typically set equal to 0. The solution corresponding to the basic variables is called the basic feasible solution. So what I have now is that s1 was 11, s2 is 20, s3 is 4, s1, s2, and s3, those are my basic variables. The non-basic variables are the ones that I set equal to 0, x1 and x2. So if I take those values and put them back into my objective function, I get minus 10 times 0, minus 12 times 0 plus z equals 0. I just get z equals 0. And it turns out that this corresponds to a corner point of my feasible region defined by my constraints. Because remember, since we're in the first quadrant, x sub 1 equals 0, x sub 2 equals 0 is one of my, my possible corner points. This solution is at a corner point, and all the simplex method is a systematic way of getting to the other corner points and determining if the solution that I'm finding, like this one, are actually the optimal solutions. It's very rare that the first point that we go to is actually going to be the one that is our optimal solution. So here's our problem. We've got this initial simplex tableau. We can get a basic feasible solution out of it, but it's usually not the one that's optimal. So what we need to do is have a way of going from the basic feasible solution that we're at to another one that might actually have a bigger value of z, because that's what we're trying to maximize. So what we're going to do is we're going to select something called a pivot. To do this, we're going to use row operations to make one of the non-zero entries a 1 and all the other entries in a column a 0. What I'm going to do is I'm going to take the entry you see in red here, the 2, I'm going to make that a 1, and then everything underneath that, I'm going to make that a 0. So let me put that up on the top of the page like you see. And so the first thing I'm going to do is I'm going to take a half times row 1, and I'm going to put the result in row 1. So I'm going to multiply a half times that entire first row. So the 2, the 3, the 1, all the zeros, and 11 get multiplied by a half. That means my first row changes to 1, 3 halves, 1 half, 0, 0, 0, 11 halves. So now I've gone ahead and I've put that into my first row. Now I need to get zeros below that. So the first thing I'm going to do is make that 5 become a 0. So I'm going to take minus 5 times row 1. I'm going to add that to row 2 and put the result in row 2. The only thing that's going to change is row 2, so the first, the third, and the fourth row don't change at all. So when I do that, the row that was 5, 2, 0, 1, 0, 0, 20 now is 0, negative 11 halves, negative 5 halves, 1, 0, 0, 45 halves. And now I've put that second row and made the change. Now I need to make a 0 where I see the 1 in the third row. So I'm going to take negative 1 times row 1. I'm going to add that to row 3 and put the result in row 3. Row 1, row 2, row 4, they're not going to change. Only row 3 is going to change. So the 1, 1, 0, 0, 1, 0, 4, when I make that change, I get 0, minus a half, 0, 1, 0, minus 3 halves. So the last thing I have to do is now the very last entry in that column is a negative 10. I need to make that become a 0. So I'm going to take 10 times row 1 plus row 4 and put the result in row 4, and that's the only thing that's going to change. When I make that change, I get 0, 3, 5, 0, 0, 1, 55. Now that I've made that change, the pivot was the 1. Now what I'm going to do is see what's the basic feasible solution that corresponds to this matrix. So the first thing I notice is now my basic variables correspond to the x1 column, the s2 column, and the s3 column. It's always the columns that have the zeros and the ones from x1, x2, s1, s2, s3. Z is never going to be a column that I'm going to put a pivot in. If I take my first row of my matrix, which is 1, 3 halves, 1 half, 0, 0, 0, 11 halves, I can go ahead and I can write out what the equation is that corresponds to that. X sub 1 plus 3 halves x sub 2 plus 1 half s sub 1 equals 11 halves. I'll do the exact same thing for the second and the third row, and that gives me negative 11 halves x sub 2 minus 5 halves s1 plus s2 equals 45 halves. The third row becomes minus 1 half x sub 2 minus 1 half s sub 1 plus s sub 3 equals minus 3 halves. Remember, I have two things that I can choose here, right? Two variables that are going to be parameters. It's easy to solve for x sub 1, s sub 2, and s sub 3 because those were our basic variables. So that means in these three equations, I'm going to go ahead and solve for the basic variables. So I get x sub 1 is 11 halves minus 3 halves x sub 2 minus 1 half s sub 1. The second equation is s sub 2 equals 45 halves plus 11 halves x sub 2 plus 5 halves s sub 1. And s sub 3 is equal to minus 3 halves plus 1 half x sub 2 plus 1 half s sub 1. Remember, I get to pick two of these variables to be anything I want, and it's going to be my non-basic variables. I'm going to set both of those equal to 0. And when I do that, I get that x sub 1 is 11 halves, s sub 2 is 45 halves, and s sub 3 is minus 3 halves. Now, when you take a look up here, we probably could have just done this straight from this matrix, because when we set x sub 2 and s sub 1 equal to 0, it's basically saying these two columns are gone, and what's left is the x1, 11 halves, the s2, 45 halves, and the s sub 3, minus 3 halves. So we really don't need to go through all of these steps that I've shown you here. If we realize what's basic and what's non-basic, we can just read the answers off of the simplex tableau. Now we do have a problem though. Remember, when we put in our slack variables, we had to be adding a positive amount. And what we just found was that s sub 3 is equal to minus 3 halves. What that tells me is this is not a basic feasible solution. To find solutions that are corner points of the feasible region, we need to pick the pivot a little more carefully. I just can't reach out and say, hey, I'm going to pick this particular entry to be the pivot. We have to pick it very, very carefully. And that's really what the simplex method has us do.